Okay, so in this problem, I've got a hollow post, 1,700 pounds up at the top, and then I got P2 kind of in the middle there, okay? Gives me a bunch of dimensions. We'll talk about those in a second. And I want to find the force at P, or P2, so that the upper and lower part have the same stress. So the first thing I need to do is basically figure out the force going through each section. And to do that, I'm going to make two cuts, one through each section, and I'm going to draw those members like this, right? So I've got P1, which is 1,700, pushing down like so. And then I have some internal load that I'm trying to figure out inside of that. And no matter where I cut it along that length of pipe, it's going to be not 17,000, 1,700, right? So this is also going to be 1,700. Did it again. Okay. Now the other one, draw that one a little bit different. We got this guy here, and then we cut it right there, right? So I've got the 1,700 right there. I've got P2, which I'm trying to find, right there. So on that, in that bottom piece, in order for static equilibrium to occur, I sum the forces in the y direction, and I'm going to find that internal force to be equal to P2 plus 1,700. So again, with most of these mechanics and materials problems are going to start with internal load statics problem, right? So you cut it where you want to find, you sum the forces, make sure that they meet equilibrium, and do that. So I've got now the forces in each section there. Okay, so the first thing now I'm going to do is I'm going to find the stress through AB. That is the top portion right there. Okay, and stress is defined by that normal force P divided by the area A. Okay, so that the normal force going through that section is 1,700. The area is basically the area of the tube, which is going to be the area of a circle is pi over 4d squared. But I've got an outer and an inner, right? Because it's a tube, so it's going to be pi over 4 times the outer diameter, 1.25 squared, minus the inner diameter, which, again, I have a thickness there. So that's going to be the outer diameter minus 2 times that thickness, right? Because I've got basically a thickness on each side going across that, right? So I've got, if I'm looking at my tube like this, right, I've got my outer diameter like this, my thickness like this. So I've got two of those thicknesses, right, to find the diameter of that middle portion that I'm got right there. So again, the area of a circle, we know it to be pi r squared. If I do it in terms of diameter, it's pi over 4d squared, right? And for this one, I want the outer diameter minus the inner diameter. So that's a big, long equation, but it's not too difficult if you kind of think through it. Okay, leaving everything in inches, I have 1,700 pounds on the top, so my stress through AB then is going to be, when I do the calculation, is going to be 1443 pounds per square inch, or PSI, which is the same as 1.443 KSI, which would be kips per square inch. Okay, so that's the stress through the top. Now I want to make the bottom the same as that. So again, I want to say, okay, the stress through the bottom section is also going to be 1443. That's going to equal the force through BC divided by the area of BC. Okay, well, the area of BC, let's see here, that is actually a solid post. No, it's also same idea. So that area is going to be pi, I don't know what just happened there. Move something. There we go. Okay, let's try this again. It's going to be pi over 4 times that outer diameter, 2.25 squared. God dang it. Minus 2 times the bottom thickness is 0.375. Then all of that squared. So it'll look like that. Okay. And then that force again is going to be P2 plus 1700. Because again, I'm trying to find P2 so it has the same stress as the top piece, right? So it's a big, ugly fraction, but it's not too tough, the algebra on it, to find P2 so that the stress through that bottom piece is equal to the stress of the top piece. And I can find that P2 then equals 1487.5 pounds, or I could say 1.49 kips if I wanted to. Okay, so again, with these problems, the first thing you need to do is find the load going through the section, each section that you're looking at. Once you have the internal load, the internal normal force, simply divide that by the area to find the normal stress in each section.